All right, so the first example for finding the big D, the domain, I created you a fraction. Now I said in the notes, you're looking for freaks. You're looking for numbers that break the function. Now, I know a lot of people will look at the top and be like, oh, x plus 1 equals 0. X is negative 1. This is complete garbage. I do not care about the top. I ignore the top. The top is irrelevant. All I care about is the bottom. The bottom cannot be 0. So what I'm going to do is I'm going to take the bottom and I'm going to set it equal to 0. Why are you doing that? Because I want to know the numbers that make the bottom 0. These are the freaks. Once I know what numbers make the bottom 0, I find the freaks, I can throw them away. The domain is what is left over. So here you have to factor. I want to use the quadratic formula. Don't use the quadratic formula. It's long, messy, and stupid. And I will give you things that factor. There is absolutely no reason for you to use that negative b plus and minus. Da, 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 da. It's too long. It's too time consuming. Factoring works really nice, right? You put the x, you put the x. Let's see. 24. Oh my God, this is so easy. I have a 24 and a 10. I'm going to put negative 12 and plus 2 because negative 12 and plus 2 makes negative 10. Oh my God, this was so easy. I got that shit all day. Let's see. Let me check the whole thing. X and x makes x squared. 12 times 2 is 24. Uh-oh. Negative 12 and, oh shit, this doesn't work. Oh no. Negative and a positive isn't a positive. Oh man. I picked the wrong pair. Oh God, I don't know how to factor. I'm so stupid. Let that be a lesson to you. There are times when the pair depends entirely on the sign. There are two different pairs of numbers that make a 10, whose product is 24. Unless you get the signs right, in order to have a positive here, you either need plus plus or minus minus. But I have a minus in the middle, so these have to both be negative, right? A negative times a negative is a positive. So 12 and 2 are not going to work. You need 6 and 4. Negative 6 and negative 4 make negative 10. Negative 6 times negative 4 make positive 24. This is very easy to F up. Please be very, very careful when you factor. If you factor wrong, then you're going to have your domain wrong because you will have found the wrong freaks. Now, I'm going to skip this part. I know that x minus 6 equals 0, x minus 4 equals 0. So you're in pre-calculus now. You can skip this shit. You can go right to the answer. X is 6, x is 4, right? You have x take away 6 equals 0, x minus 4 equals 0. We don't need to write that anymore, right? We're at a higher level. So what do I know about these two numbers? You're like, I'm done. This is my answer. This is shit. These are the freaks. Freaks. These two dudes break your function. If you take 6 and plug it in here, but 6 plus 1 is 7. Who cares about the top? The top doesn't matter. The bottom matters. If you put 6 down here, you will get 0. If you put 4 down here, you will get 0. So these numbers break the function. So the domain is all real numbers except x equal 6 and 4. So if you want to write it as a set, you put the weird squiggly ass thing. It's a set of all x such that x is not equal to 6 and 4. It's the same damn thing. I don't want you to write this as an interval. I'll show you why. You're like, but why not? It's convenient. It's not convenient. It's actually very inconvenient. If you were to write this as an interval, you'd have to write negative infinity to 4, union, 4 to 6, union, 6 to infinity. This is too much writing when all you can say is all real numbers except for those two dudes. This is too much. I don't want you to have to do that. I mean, you could write it on a number line and show me with the holes. But this is how I want you to write it when it's a fraction. Just tell me all real numbers except for the freak and the other freak, right? You get two freaks, 6 and 4. All right, so this is what you do when there's a fraction. Set the bottom equal to 0. Solve it by factoring. Don't use the quadratic formula. Get the numbers and throw them away. Very simple. All right, basic. Works. So second example has a radical. So again, I'm looking for the freaks. I'm looking for the numbers that break this. What numbers break this? Numbers that create a negative on the inside. So look, if x were 0, I would have radical 15. That's okay. Let's say x were 7. I'd have 15 take away 35. That's negative 20. Uh-oh, bad. So I'm looking for, now what are you going to do? You sit there and, try numbers in your mind? You can't do this. So what I wrote in the class notes was, take the inside and set it equal to 0. And solve it. Why don't we move this dude to over there? I don't think you need me to write plus 5x plus 5x. I can write that if you really wanted me to. I'll be nice and write this stuff like we're in the 3rd grade. So x is 3. And I'd rather it be on the other side, but whatever. Now, I'm going to take that number and I'm going to put it on the number line. Now, first question, does 3 work? Is he a freak or is he not a freak? So I'm going to take 3 in my mind and put it there. 15 take away 5 times 3 is 15 minus 15, which is radical 0. Like, you can't do radical 0. What number times itself is 0? I mean, come on, man. Radical 0 is 0. This is defined. This is cool. So this dude works. Okay, now notice, he splits your number line into 2 pieces, left and right. One of those sides is freak, and one of those sides is cool. Your job is to figure out which side has the freaks. So why don't you just pick a number on one of the sides. Let's say we pick 4. This is going to be like a little test point. I'm going to put 4 in there, and I'm going to see what happens. If I plug in 4 and I get a negative, then I know that this dude and everyone on his side is a freak, and I throw them all away, and the other side must be good, but I'll check that side too and make sure. So look, I'm going to try x is 4, right? So plug 4 in. I'm doing f of 4. I don't need to write that. Look, this is part of your work. I have to see it. You're like, I'm not doing this. I'm going to do this in my mind. 5 times 4 is 20. 15 take away 20 is negative 5. This fails, right? This is BS. So that means that this dude is a freak. That means that everyone on his side is a freak. These numbers don't work. Any of them. Any number bigger than 3 that you plug into this dude is going to give you a negative inside, and hence undefined BS. This doesn't work. All those numbers are freak. Now, just to make sure, I'm going to pick a point on the other side and make sure these numbers are cool. I can pick any number I want. I'm just going to pick a negative. Pick -1. Pick -100. Who gives a damn? So now I'm going to take f of -1, right? Put -1 here and here. Pop them in there. A negative times the negative is a positive. Yay! Oh, man, it worked. Radical 20. Oh, I got to break that down, don't I? No, you don't. Give me a break. No, but it's radical. It's 2 radical 5. Don't do this shit. It works. Boom. So what's your domain? All those dudes. Well, what's way out there? Negative infinity. So your big D is all the numbers that are less than or equal to, remember, you got to put the bracket. This is why I had you do this. This is the only reason that I did the interval notation with you, is that you'd be able to write the domains of the square root dudes using this notation. So all these numbers to the left of 3, cool. All the numbers bigger than 3, uncool. Freaks, they're bad. They break the function. Now, number line, interval. How else are you going to write this? I mean, you can write this in the set notation. You can say, I want the set of all x such that x is less than or equal to 3. This is going to lead me to one very important point that I'm about to say. All right, so this is the only way you can write the domain here. I mean, you can write in words all numbers less than or equal to 3, but that's kind of stupid. I'm going to ask you to do this anyway. This is the one I'll ask you to do on a quiz or test. I will say to you, find the domain of this function as an interval, and you have to write your answer like this, okay? Now, I'm going to pause. All right, the third and final example of the big D. We want to find the domain of this dude. Now, as I mentioned, though I stopped recording when I said it, this is a radical. It has to be 0 or larger. It has to be positive or 0. So some people will take the inside and make it bigger than or equal to 0. This is called a quadratic inequality, and it is beyond your ability to solve at this point. And this is not trivial to solve. So this technique of just setting the inside bigger than or equal to 0 and solving an inequality doesn't work. This is why I teach you the technique of first figure out where the inside is equal to 0, put those numbers on a number line, and then create test points and see what works and what doesn't work. Now, I can divide everything here by 2, right? No, you can't. Yes, you can. This is equal. Divide away the 2. Now, whatever you want to do. If you want to use square root, you want to factor, I'll factor. This is a difference of perfect squares. So you get +2 and you get -2, right? You get -2 and you get +2. Now we're going to put those numbers on the number line. Sorry, my number line isn't so perfect. Now, these numbers are okay, right? How do you know they're okay? Because they make a 0. But how do you know 0 is okay? If you plug in 2 or -2 here, you get 8 minus 8, which is radical 0, which is 0. These numbers are not freaks. These numbers are okay. But notice, I have 3 regions to test. Left, middle, right. I don't know where the freaks are right now. I don't know. I have to determine where the freaks go, and then I'll know who's cool and who's not cool. So I got to pick numbers in each region. I'm going to put little circles around them. Maybe I should do it in red. I mean, I'm just going to pick the most convenient number that I can. These are test points. What am I supposed to do with them? I'm going to plug them into the original function and see if I get a positive or if I get a negative. If I get a negative, freak, throw it away. If you get a positive, it's cool. So let's do it kind of fast and half-assed, right? I'm going to put -3 in there. I mean, this takes time. You can't do it in 2 seconds, although I'm going to kind of cheat a little. That's 9 times 2 is 18. This is cool. I see it's 10. It's radical 10. Okay, it's radical 10. So this is okay. This is good. These numbers work. If one dude on that side works, they all work. If one guy there fails, they all fail. That's the way this works. You can't have one guy in that region working and then the next guy doesn't work. If one guy works, they all work. Now I'm going to try 0. I hope you can see 0 is not going to work kind of quickly. Put 0 in there. 0 squared is 0. Times 2 is 0. And then 0 take away 8. No, it didn't work. Freak. Freak. All those numbers in the middle. Any number you pick there. You pick -1, freak. You pick 1, freak. You pick a half, freak. You pick 1.9, freak. 1.9999, freak. Any number that you pick that is between -2 and 2 will be a freak. You only had to test one dude, and then you know which ones don't work. Now I'm going to test out there, but if we have some common sense and we understand how the squares work, this is going to work. It's going to give you the same number you got there, right? That's 9 times 2 is 18. So he's cool too. So what worked? All these dudes worked. All these dudes worked. Who didn't work? The middle. This middle piece did not work. So the middle piece gets thrown away. So what's way out that way? -infinity. What's way out that way? +infinity. So how do you write your interval? You have to be very careful here. You want to take the endpoints when you write your intervals. I want to use different color to really emphasize. Okay? So who worked? All the numbers that are between -infinity and -2, including -2. And big ass U for union, right? From 2 to infinity. This is your domain. This is your big D. I'm not going to write this as a set, okay? I'm only going to write this answer as an interval. All the numbers smaller than or equal to -2, and all the numbers bigger than or equal to +2. All the numbers between -2 and 2 fail. -2 works, and 2 works. Those are not freaks. The freaks are in the middle. All right, so set the inside equal to 0. Solve it. Put those numbers on the number line. Pick a test point in red. Pick a test point in each region. Plug them into the function and determine if they're positive or negative. Positive, cool. Negative, freak. Okay? So the negatives you throw away. You might have had a freak on the ends, and then your domain would have been the middle piece. You cannot solve this one with an inequality. If you did 2x squared minus 8 bigger than or equal to 0, fail. You're not going to get this. You can't get this. It doesn't work that way. That's not how you solve a quadratic inequality. So you have no choice but to use this technique. So if I teach you a technique, I expect you to use it on every single problem. Yes, on the more basic one, you could do it, but not here. Okay? So there's the last example.